talk about memorizing multiplication facts and give you some great ways to teach and to practice memorizing the facts. I'm going to give you a brief understanding of why, but I'm going to cover that in a podcast much more in depth. So this is just basically some strategies and some activities you can do to help your students memorize multiplication facts. I'm going to talk about the why more in depth in podcast episode 17, which is going to come out shortly after this video. Basically, fingertip facts or having facts memorized allows for deeper understanding because it takes some of the pressure off of the calculations. It makes for fewer mistakes and quick calculating. And it gives students the ability to recognize common factors, which is very, very important as they go on in mathematics class or in their study of math. One of the best ways to teach students how to memorize their multiplication facts is having them memorize their skip counting and patterns that they might notice when they're skip counting. For instance, most students can count by twos, but they need to be able to do it very, very well and very, very quickly because twos, you can build on the foundation of counting by twos and learn the fours because your fours are basically every other two. Then there is another pattern. As soon as the ones digit goes to 0, then the ones digit repeats what it was after that. So for instance, here with your 4, 20 ends in a 0. Then it repeats the ones digit. It doesn't repeat the tens digit, but you notice the next fact is 24, and then 28, and then 32, and then 36, and then 40. So the ones digit repeats 48260, 48260, and that continues throughout all of the rest of the fours. And you can use those same two ideas for learning your eights. So for instance, your eights are every other 4. So if you use that to get your first 5, you can use the ones digit pattern to more easily figure the rest because generally kids can memorize the first 5 skip counting numbers pretty quickly. It'll take some time to get the rest of them down, but those first 5 generally come very quickly. And then as you can see, the ones digit pattern for the eights repeats with the eights. And it's always 2, 4, 6, 8, and 0, but in different orders. So the 4s went 4, 8, 2, 6, 0. The eights go 8, 6, 4, 2, 0. And then that repeats with 48, 56, 64, 72, and then 80 ends in a 0. These are the skip counting patterns that I'm talking about. And while teaching this in my classes, and I taught it in the 7th grade class because I had such trouble, it was so difficult to teach fractions and factoring and pre-algebra when a student didn't have their multiplication facts memorized that I taught multiplication. Every week we did a multiplication timing, which I'm going to tell you about later on in this video. But I taught them these patterns. So we would see the pattern in the twos, which like I said, by 7th grade, most kids can count by 2. But most of them didn't notice the ones digit pattern, or the every other 2 is a 4, and the every other 4 is an 8. And those patterns continue actually throughout most of your skip counting facts. Take a look at this next one. 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. There are several songs on the internet that can help you memorize those. Those are great songs. But then as you move from your 3s to your 6s, because 3 times 2 is 6, just like 4 times 2 is 8 and 2 times 2 is 4, when you double it, you use every other one of the previous one. So for instance, every other 3 is a 6. 6, 12, 18, 24, 30. That's easy to get the first 5. And then the ones digit pattern is how you can work to get the final 5 or the last 5. And a lot of people go on to memorize 11s and 12s also. Sometimes it depended on the class. Sometimes with my students who were struggling, I didn't do 11s and 12s. It was good to just get single digit multiplication down, and that worked for them because then you can use it to multiply 12s. Because 6s sometimes can be a little bit difficult to memorize. Sometimes it's difficult. If you don't have your 6s down, then memorizing your 12s by using every other 6 could be really challenging. But 12s are easy in the fact that all you're doing is adding 10 and adding 2. Two numbers that are really easy to add. So you just add both in sequence. So either add 10 first and then add 2 and you'll get the next one, or add 2 first and then add 10. Now, I usually teach it to add 2 first and then 10 because of the jump from 48 to 60. A lot of kids will just go 2, 4, 6, 8, 0, 2, 4, 6, 8, 0, and then go 1, 2, 3, 4, 5, and they'll put down 50. And I'll have to pause and I'll say, wait a second, take a look at that. Is 50 12 more than 48? And then they say like, well, no, it's only 2 more. So what should it actually be if it's 12 more? And then they see that it's 60. Because if you do those simple patterns like 2, 4, 6, 8, 0, and then 1, 2, 3, 4, 5, they don't notice when they skip one or when it alters. But if you teach them to add 2 and then add 10, it becomes a little easier. So for instance, 12 plus 2 is 14. 14 plus 10 is 24. 24 plus 2 is 26. 26 plus 10 is 36. Or you could add the 10 first. 36 plus 10 is 46. Plus 2 is 48. 48 plus 10 is 58. Plus 2 is 60. And it goes all the way down the line like that. That is the pattern that I taught on the 12s, is the plus 10 and plus 2. I would teach plus 10 and plus 1 with 11s, because once you get past 9 times 11, that repetitive pattern changes. And I want the kids to see that 11s are not just 1, 1, 1, 2, 2, 2, 3, 3, 3, which is what they originally think when you get to 11 times 11. So make note of these and make sure that as you teach them, you repeatedly teach these patterns so that they remember them and they can recognize them. Fill in the blanks, like perhaps on one of the pages, have the tens digit of the 6s down and have the first 5, and then have them fill in the rest of them. Just the ones digit on the rest of them to teach them the ones digit thing. Or have them circle every other 3 and compare it to their 6s. These patterns, though, when you teach them, you have to do it multiple times. Teaching it once does not mean they're going to remember it. You have to repeatedly teach it and allow them some time to explore it. So like circling every other 3 when you first teach it, then they will see, oh, 6, 12, 18, 24, 30. That's your 6s. Now, why do you suppose that is? Well, you know what? It's because 3 times 2 is 6, so every second one is a 6. You know what 3 times 3 is? 9. Every third 3 are the 9s. Every fourth 3 are the 12s. Those jumps get kind of big and much more difficult to navigate when you're writing them down, but they are patterns. And as soon as students start learning to look for patterns, they start seeing them everywhere. And that's really what learning algebra is all about, is recognizing a pattern and being able to write it in an equation form. And now we have our 9s. So many patterns in the 9s. It's great. First pattern I generally taught students is that after 45, after the first 5 9s, the digits reverse. So 45 is 54. It's almost like a mirror image of their first 5. 45 becomes 54, 36 becomes 63, 27, 72, so on and so forth. I would also have them compare the digits. So 9 is 9, but what's 1 plus 8? What's 2 plus 7? What's 3 plus 6? What's 4 plus 5? That's true for all the 9s. It's also true for the 3s. Also for 9s, I would teach them to add 10 and subtract 1, because 9 is 10 minus 1. So 9 plus 10 is 19, minus 1 is 18. That's another way to get your 9s from the one that's previous to it. And why plus 10 minus 1? Because 10 minus 1 is 9. When we were exploring patterns with the 9s, I would also teach students or show students this pattern. But please don't teach it as a way to do the 9s on the multiplication table or on the multiplication chart. It's a clever little pattern that shows up in the 9s, in the first 10 of the 9s. But the problem with it is that there's no connection between the factors and the product of your nines. For instance, it doesn't help a kid understand that 7 times 9 is 63. All they know is they have to write it all out to see that 7 times 9 is 63. So while it's a clever pattern and it's a neat little way to do it, I would always steer kids away from doing that on their multiplication timing because there's no connection to the actual factors and product. And that's our ultimate goal in having them memorize their multiplication facts. Once you've explored your multiplication skip countings, here's some neat little activities to help you practice with your students. This first one is called What Comes Next. And I made a Google slide and also a PowerPoint that had them flash whenever I tapped the screen, that had the numbers pop up whenever I tapped the screen. So it made it a little easier, but you would just say, what comes next? And I would say, okay, we're doing the 4s. What's the first one? Kids would say 4. So I'd tap it and a 4 would appear. Next thing, and before I would tap it to show the next one, the kids had to say it to me. So it's a neat little activity of what comes next. But then also once you figure that, what comes next, or once you point that out, have the students look for patterns. And I would always arrange it like this, the 5 numbers on top and 5 on the bottom, because then they can see that ones digit pattern a whole lot easier. And then I would cover up those last 5 and have them tell me, okay, how does this help you figure the next one? And we would have that discussion. The next one is called the disappearing sequence. And I would have the 4s all up on screen like you see, and then every time I tapped, one would disappear. And we would pause and say the whole thing. So 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and then I would tap and another one would disappear. And I generally started with the easier ones. And then we would say the whole sequence again. And each time we say it, one of the numbers would disappear, eventually getting down to where they were all disappeared and they had to say the whole sequence by heart. Once you practice all of your skip counting, then there's the timing the multiplication tables and what I call sprints to help students gain quickness with it. So they get faster and faster at it. And all this requires is a multiplication table and blank multiplication table. And I would photocopy bunches and bunches of them because we did this multiplication timing every single week. And the ultimate goal was to complete it with no mistakes in less than 5 minutes. Now I'd start out the year, first quarter's goal, they needed to be done in less than 8 minutes, and then less than 7, and then less than 6, till finally it's less than 5. Most students, by the time they get to January of a school year, are pretty close to 5 minutes already. It doesn't take that long, especially for young minds, to pick up on things like this, on your timings and your patterns that you practice over and over again. Because the repetition, especially with a young mind, a young brain, it sticks better. You can do it in stages, and when I tutor, I actually do it in stages. So the younger kids will, and I do this with kids as young as 3rd grade. We will multiply 1s through 5s, and I have them try to do that in less than 2 minutes, and then add a little time, and they have to add the 6s, and then I add on the 7s and add a little bit more time, such that when they get to the one doing timing 1 through 8, that it's 2.5 minutes. And that's half of the goal time and over 2/3 of the chart, or 2/3 of the chart that they've already got done. So then they have half the time to do the last 4 rows of the chart. Makes it really nice. Another way you can do it is to just time 5 minutes and see how far they get. And every time they time it, they need to get a little bit farther and a little bit farther. How do you write it on the multiplication table? And does that even matter? I found that it actually does. So on the multiplication table, I know that there are some people who say, well, you just fill it out, and the ones that you don't know, you leave blank, and those are the ones that you practice. I didn't find any success with that because there's no way to connect it to the ones that they already know. And skip counting, I found, is the best way to connect things that you don't know to things that you do know. Because you always start out with lower numbers like 6, 12, 18, 24, and then you can work into the higher numbers by either counting on your fingers or adding 6 in your head. There's another thing. I've heard people say, well, you go across and you do the ones, and then you go down and you do the rest of the ones. And then you go across and down and cross and down and cross and down. And that's really easy for the first 2 lines in either direction. Once you get to the 3s though, because you're not starting at 3, 6, 9, 12, you're starting at 9. And so 3 and 6 are already there, and they have to start at 9 and count by 3s. And there's something in your mind that has a hard time doing that. And when you do it that way, you end up having to memorize 24 sequences. What I told my students to do is to just do each skip counting set in order. So you do your 1s and then your 2s and your 3s and your 4s and your 5s and your 6s and your 7s and your 8s, your 9s, your 10s, your 11s, your 12s. It didn't matter whether you go horizontally left to right or vertically top to bottom. Either way, I had students that would win my multiplication, my fastest multiplication timing award, and it didn't matter which direction. I had some that would go horizontally, I had some that would go vertically. That didn't seem to make a difference in the timing. So it would look like this. You'd write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then here's where your skip counting comes in really handy, because then you're actually writing what you were skip counting: 2, 4, 6, 8, 10, 12, 3, 6, 9, 12, 15, 18, so on and so forth, throughout all of this sets. And I would actually do those exercises, those activities, before we would multiplication time. At first quarter, I would set apart probably a block of 20 minutes to just practice multiplication. As we got through the year, I needed less and less time to do that. And I had so much more success with students learning about factors and products and fractions and all of that because they knew their multiplication table so much better. And here's what it looks like vertically. Vertically, most students prefer to do it vertically. And once you get through your 5s, most people are able to do their 1s through their 5s in less than a minute, because once you've written them as often as we did, they got so much faster, because the only ones that are really any trouble to memorize are your 3s and your 4s, and they're not that hard. So that leaves 4 minutes to do the rest of the chart. And speed comes naturally as you practice your accuracy. And I always told my students, it's not about the speed, it's about the accuracy. Because it doesn't matter if you can complete the chart in 2 seconds if all of them are wrong. There's no point to that. So number 1 goal is to be able to write them all accurately. Number 2 goal is to do them accurately and quickly. And the quickly part really shows how well you do have it memorized. A multiplication sprint is something that I came up with to help students practice one multiplication for the purposes of timing the multiplication chart. And what you do is you use just a plain piece of notebook paper or scrap paper. It doesn't have to be fancy. And you're going to time for 1 minute. But first you're going to write down what's like an index row. So you write down the row that you're going to practice and you make sure it's right. So that's the key. You have to make sure it's right. So if you're going to practice your 3s, you write 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, but you double check it to make sure it's right. Because what you're going to do from here is time 1 minute and simply copy that. Yes, they are going to copy it, not cover it up and try and do it without looking. They're going to look at it and copy it. And the purpose in copying it is that it gets a pattern established in their head. And as soon as that pattern gets established, it becomes easier and easier and easier to recall. And you're going to time for 1 minute. So you set a timer for 1 minute. Make sure it's going to have an alarm that's going to sound so that everybody can hear it. And then I say, on your mark, get set, go. And then they just write from top to bottom the sequence over and over and over again. If I catch any writing across like 3, 3, 3, 3, 3, 6, 6, 6, 6, 6, 9, 9, 9, 9, 9, I tell them this, and this is true, 100%. You're not trying to memorize each number. That's not going to be helpful. That is a complete waste of your time. You're trying to memorize the order. So in order to do that, you have to repeatedly write the numbers in order. So you always have kids trying to beat the system, and I kind of respect it. Another great way to memorize things is through songs and chants. Now, I'm not very good at writing songs. I'm a terrible songwriter. I always wished that I could write songs because that would have made learning multiplication a lot easier, but it's just not my strong suit. However, YouTube and other video platforms are an excellent resource for other people who can write really good songs. And those can help students, you teach them a song and it helps them to learn to memorize. This next activity I came up with myself to help keep students reciting on beat, as we just simply said, the skip counting chants. And it's called bounce count. And it's simple. You have a ball and you bounce it, and every time it bounces, they say a number in the sequence. So I would do this in front of the classroom too. I'd have a volleyball and I'd bounce it and catch it and they'd say it. And we'd practice it, and this is how we would warm up before we did multiplication facts later in the year when we didn't spend as much time practicing our skip counting. But you can also do it as a game. Here in this video, I'm going to show you a way that I do this with some of my tutoring students. So they're learning their multiplication facts. It gets them up out of their seats. Their pulse rate is higher, so therefore they're much more alert, and they're learning to count in sequence in time. And a pattern naturally emerges. So you'll find that when you're saying 2, 4, 6, 8, 10, 12, 14, 16, 18, a chant, a natural way of saying it on beat emerges. Now the cool thing about this is you can gamify it, in that you can bounce count, and if somebody says a fact incorrectly, then you have to start that set all over again, and they get to practice it again. And they get to practice that mistake over and over again, so that hopefully it is not a mistake that sticks, but it gets fixed. All right, so we're going to do our twos. All right, 2,
4,
6,
8,
10,
12,
14.
18.
Oh no, it's 16. So now we have to start over again. 2,
4,
6,
8,
10,
12,
14,
16,
18,
20,
22.
24.
Yay! Let's do the 5s, but let's do it super fast since you're really good at 5s. You ready?
Okay.
All right, 5,
10,
15,
20,
25,
30,
35,
40,
45,
50,
55,
60,
65,
70,
75,
80,
85.
90.
Ah,
Oopsie. Well, at least we finished it.
that's all there is to it. The bounce count game can be done with lots of kids in one big circle. In some of my smaller classes I would do this. We'd go out on the parking lot where nobody parked, stand in a circle, and we would bounce the ball to each person in sequence around the outside of the circle. And I would emphasize that the kids had to say the number while the ball was in their hand. They couldn't just go and then bounce while they're saying it, because then the ball gets a little out of control. But it's like 2, boom, 4, boom, 6, so on and so forth. And then gamify that also, in that if somebody says an incorrect number in the sequence, then they're out, and the circle gets smaller and the circle gets smaller until there's only 2, and then whoever is last is your winner. And it can go faster. So if one kid knows like the 8s really well, 8, 16, 24, 30, 32, so on and so forth, then, and the other person doesn't know them as well, if the other person says an incorrect number for the sequence, then they're out and you have one sole winner. And that always makes it fun because I enjoy a good competition. In fact, sometimes I would get involved in these competitions and the students would compete with me, and I'd always tell them, if you can beat me, then you get a free homework pass or something big, because that's hard to do, because I've been doing this a really long time and I'm really fast at it. But I did have students beat me on a fairly regular basis. This next game I made up sort of out of desperation, trying to help kids learn their multiplication facts. I had all sorts of adding games, but I didn't have any memory multiplication games that were not just writing your multiplication facts over and over or going outside. So I actually made this game out of index cards. So you have the fact on one side and then the answer on the other side. And you lay them out in an array like this. And the rules are simple. Each kid takes a turn, and they turn over as many cards with the same product on the back as they want. But they have to know all the ones that make 6, or all the ones that make 8. and then they can turn them over and those become their cards. Now I added a point value or an extra point value thing in that I drew symbols on the cards, and the symbol gave them so many points. There were 22 blank, 40 with a plus sign, 30 with a squiggle, 20 with an X, 10 with a dot, and 5 with a dot with a circle around it. And that's how many points they got. So once they collected all their cards, they then added up their points and they saw who was the winner. And there was one time I was playing with some tutoring kids, and one of the tutoring kids got 2 of the 500 dot ones. And even though they had fewer cards, they won by points. So that was really fun. But let's say that somebody chooses to do 6. So they turn over 2 times 3 and then 3 times 2, the commutative one. And then they turn over 1 times 6, but they don't notice that 6 times 1 is also on the board. Well, whoever's turn is after them can snatch up any of the cards that they missed on the first of their turn, and it doesn't take their turn. They just kind of get bonus cards. And you continue. I would put new cards in the spaces. So I would usually do like an 8 by 5 array because that gives you 40 options, but as big array as I could fit on the table. And then I would fill it in with any extra cards that I had until I had no more extra cards. And then you play until you can't play anymore. And yes, it is possible to turn over a card that does not have a match, like 1 times 1. There's only 1 of those. And if that's left, if that's all that's left, then you can take that card. You don't have to have 2 of them that you can take. It just hit me that this could also lead into discussions about prime and composite, because the prime numbers will have only 2 cards on the field, 1 and then itself. So for instance, 3, there's only going to be 2 of them on there, 1 times 3 and 3 times 1, and that's it. 1 is not prime because it's only on there once, and you have to have 2 factors in order to be prime. Any that are on the board or could be on the board more than once would not be prime. But the reason I say could be is because sometimes they have another factor or another product, but it's just not until after 12, and so not all of them are on the board. Lots of discussion there. In this next sequence of videos, I'm showing you some of the reasons why memorizing multiplication facts are so important. Teaching is just generally hard, and it gets harder as you go on down the line if the students you have in front of you don't have the prerequisite skills to understand what you're teaching. And these are the basic things you need to understand in order to divide, even long divide, factor, and there's so many more things that are made infinitely easier when students have their multiplication facts memorized. As I've said many times before, math becomes so much clearer when you have a solid understanding of basic addition, subtraction, multiplication, and division. Congratulations, you have made it to the end of this video. And I hope that this helps you understand how important it is that students have their basic facts memorized and how much easier your job will be and the people who come after you, their job will be to teach when the students have that solid foundation built up. Thanks for watching, and I'll see you in class.